Hello everyone, how's it going? In this video, I wanted to go ahead and show you how to improve render times by a factor of up to 100. I know this sounds very over-exaggerated, but trust me, the tips I'm going to be showing you today will help you achieve that really fast and really easily. Why will it be easy? Well, because it's mostly based on the render settings and not by actual optimizations of your scene. But don't worry, I'm going to show you some tips about optimizing your scene right at the end of the video. So stay tuned and follow along. We're going to be using this scene and I left everything set to default. You just downloaded Blender, you have your own scene, you've made your own scene, it looks great, and you might possibly want to make an animation out of it depending on the render times, but you find an issue, the image will take you 2 hours at least. If you want a 1-minute animation, this might take you days on end to render everything. Not practical at all. So I'm going to be showing you how to take render from 2 hours up to 1 minute, 2 minutes, or even less so. This scene with the default settings takes around 2 hours and a half. I'm not going to render it in front of you since it takes massive amounts of times, but from the default settings, which I'm going to be showing you right now, it will make sense for anyone that has rendered using the default settings and using the CPU only. So the first aspect we need to consider, what is our rendering device? Cycles can handle both CPU, GPU, or use both. So that's an amazing aspect. We're probably going to be using an RTX card. So most people have NVIDIA GPUs. Now, you might go ahead and use CUDA, since that's what most people are knowledgeable about or familiar with. But in our case, RTX is extremely useful, so we're going to be using optics. Now, optics works for any RTX card or any card that is actually new enough and have enough power to support this feature. You can go ahead and Google what cards support that, and if your cards supports this, definitely go ahead and use it. On the other hand, if you have an AMD card, you need to be using HIP, and if you have an Intel card, you need to be using one API. For the most part, NVIDIA GPUs for Blender specifically and V-Ray GPU and Octane work way better than any other card on the market. So that's what we're going to be using. I'm also going to be using my AMD Ryzen 5700X as well as an RTX 4070 in this case. So we've got this going on. Make sure to save your preferences or enable autosave preferences since you're going to be using that for every scene from now on. So this is extremely obvious, but I figured I need to show this in case any novice artist will want to go ahead and learn this from scratch. Now the second thing, to actually use your GPU, you need to go ahead and enable GPU compute from the device section. So we're going to be using that. In this case, we're also using cycles. Now after working on our device settings, we're going to be taking a look at our output, mainly the resolution. So the resolution correlates to the render times immensely. A 2K render won't take near as much time as a 4K render. A 4K render will take 4 times the amount of rendering time, if you're lucky. So in this case, I'm going to be using 191 by 180. So the regular aspect ratio of most screens today. After that, we're going to be enabling our sampling settings, mainly the noise threshold. What is the noise threshold? Well, It's a nice way of saying adaptive sampling. What does this mean? Well, usually, if you keep this unchecked, your samples would be strict, so every pixel in your scene will be getting 4096 samples. So what are even samples? Samples are the number of rays casted per each pixel. But some pixels do not need as much samples. Glass, for example, needs a lot of samples. Underexposed scenes need more samples to be illuminated well and remove all of the bad noise. So enable this. And for the max samples, in this scene, most scenes, you won't need anything more than 200 unless you've got a lot of glass or you're attempting to render caustics inside of cycle. In this case, I'm going to take it from 4096 to 200. For the minimum samples, just to be safe, I'm going to go ahead and add 10. And you can keep it at 0, it's fine. But I recommend keeping it to at least 10. So just for the sake of comparison, this scene took 2.5 hours to process everything. With the default settings using my CPU, it might seem way too over-exaggerated as well, but if you are familiar with CPU rendering, you know for a fact that it's extremely slow, as well as the value of 4000 samples. No one uses that for the most part. So keep the noise threshold to this value, and if your scene has too much glass, or if it's too dark and needs to be illuminated, or it even has a lot of depth of field, make sure to even go ahead and lower that. So for this section, that's good enough. Now, the next thing we will want to go ahead and do is jump to our light paths section. So let's just close the sampling section and jump to the light paths section. For the light paths, for the most part, they are way too over-exaggerated. We don't need a total of 12. Let's just set it to 4 times. For the diffuse, let's set it to 2 times. Same thing for the glass. And for the transmission, we don't have any glass in the scene, so let's just set it to 1. Volume, unless you're rendering clouds, you don't need to actually add more than that. Or heavy fog, but experiment with this, not necessarily will it improve the look of your fog or mist. So keep it this way. Now transparent, it won't add in render times, and it helps eliminate the dark spots that we can see when rendering a lot of vegetation with a lot of opacity maps. So make sure to have it set to even 1000. It won't make too much of a difference, but it's necessary. Otherwise, you will start seeing black halos around your geometries or anything with the shader that has an opacity map plugged into it. So this is good enough for our max bounces. After that, we can go ahead and play with the clamping. In this case, after doing many tests, it doesn't make a difference at all in my case. What makes a difference is disabling caustics, refractive and reflective. Unless you're rendering glass or you're rendering a car, no need to have that enabled. Cycles in general really struggles with caustics if you compare it to something like V-Ray, Corona Renderer, or Octane, especially with the new Octane solver. It's amazing. Blender is still new to caustics, so give it some time to improve. Now after that, your scene should already improve immensely. The biggest improvement will be from the device you're using. From the CPU to GPU, this will cut render times by 4 times at least. So after that, what we need to do is try something different, right? Something that a few people recommend, but I might recommend it to you if you know what you're doing with it. So this is what the scene looks like without this thing enabled. What's this thing? It's the FastGI approximation. So enable it. Did anything change? I don't think so. Let's zoom on the shadowy parts and see if anything changed. So let's enable FastGI approximation. I can't see any difference. Even without the YouTube compression, rarely any difference, but this is very reliant on the type of scene you're going ahead with. And some scenes using the FastGI approximation will be a horrible idea. It will eat the same render times, consume the same memory, but will look absolutely horrible. In this case, it makes the world of a difference in terms of render times, and you can't even see any noticeable drop in quality. From what I noticed, it does add some bluish tints if you're using a sky with a lot of blue in it. But in our case, the sky is not too blue, and we don't have that problem. You might go ahead and compensate that inside of Photoshop, up in the contrast and up in the actual playing with the white balance. So up in the value of the white balance up to 7000, for example. So we've got this option ticked. Now, what is FastGI approximation? It's an alternative and a different way than using GI. So it uses AO, tinted ambient occlusion, to try to imitate how global illumination works. And surprisingly, it works well enough. So you might as well go ahead and play with the settings here. So you might go ahead and try add. As you can see, it brightens the scene a lot. Using replace, the scene is darker. As you can see, mainly on the lower portion of the render here. But if we keep it at replace, we might as well go ahead and up the actual bounces. This will make it slightly better. But it doesn't make a difference in my case at all. As I mentioned earlier, go ahead and just eyeball this out, since it differs greatly from one scene to another scene. In the case of having too many shadows, it works okay, but in the case of having slightly less dark shadows and way more light inside of the scene, you might start losing the realism. So let's keep this set to default. Now the second thing is, we've got a volume here. So we're just using a simple mist or fog shader with the principled BSDF. You might go ahead and lower the step rate and the max steps. Now for the max steps, I'm going to go ahead and get this to, let's say, 200 steps. Now this will be extremely obvious while rendering VDBs. So clouds, explosions, don't go way too low, but don't go way too high. So lowering this, you might go up to 64 even in this case. We don't need anything more than 64. This will greatly improve render times. And you can go ahead and take a look at some comparisons on the Blender documentation. If I'm not mistaken, they have a couple of comparisons between the look and the render times. After doing that, one thing that a lot of people overlook is going ahead to the film section here and up in the width or the pixel filter width. So let's try 3, for example. So let's just take a look at how this looks. 3 and 1.5. There is a difference. I'm sure that you won't see it, but there is a big difference. Now some people might say, I get this way too often. People check my Instagram, they see renders made in Corona or renders made in V-Ray, and they tell me, how come Blender renders don't look as sharp as the other renders that you make? Well, the simple fact that the width in the pixel filter makes a huge difference. This is overlooked, but it does make a gigantic difference in terms of sharpness. The lower the width is, the more sharpness you will get. The bigger the width is, the more blurry the image would look. Now, don't take this way too low, otherwise you're going to start having some anti-aliasing issues. But having a width of 1 pixel will add a lot of sharpness to your image, and it will start looking more like the default Corona or V-Ray renders. In this case, we're going to be doing the opposite. All we care about is making render times way faster, even if it hurts the quality of the image and the realism a little bit. It's all about compromises at this stage, especially if you are rendering an animation. You know, a big difference can be made by having less realism, so 5% less realism and less quality. That, if you have motion blur or if you have depth of field, no one will really notice. I mean, especially if people will look through their phones on their small phone screens and on Instagram with all of the compression, it won't make a difference at all, trust me. So instead of giving a render 200 hours, it's going to be taking 10 hours or 20 hours, a huge difference that it becomes worth it. So this is a compromise you should think about. In this case, let's set this to 2, which is a good value. Now, the other thing is that we need to go back to performance. Now, performance, you should leave this as default for the most part. You might play with the tile size, but in this case, the default works the best after doing a lot of tests. But if you are running a animation, this will be very relevant. Make sure to be using persistent data. So what does this do? It uses more memory, but it makes the initialization of each render frame way faster. Not even that, but it cuts it out completely. So you only process the actual data of 1 frame, and it does the rest based on that 1 frame. So it doesn't need to recompute the VBH, for example, the BVH, excuse me. It doesn't need to recompute the geometry, the displacement, anything, unless you're using adaptive displacement. Then it would need to compute that per each frame. But other than that, I don't see a reason as to not use it. From what I've seen, it doesn't have any side effects, and it should be set by default, in all honesty. It does increase memory usage, and it might do that substantially if your scene is way too big, so you might need to run some tests before doing that. You don't want to go ahead and run out of memory while rendering 300 frames and leaving the PC. You will have wasted a lot of time doing that. But this is something to most definitely do. Even for test renders, you have to do this. So tick this button here, and you've practically improved your scene in less than 2 minutes of render settings. So let's try something. Let's take a look. For context, using the CPU, it took around 2 hours and 20 minutes exactly. So let's say 2 hours and 30 minutes. So let's render this with these current settings and see how it looks, how much time it takes. As you can see, it's initializing the render, computing all of the textures, the VBH and everything. It finished it up, and now it's rendering everything. So as you could see, it's extremely fast using the GPU. Way too fast, actually. And it's almost done already, and it's done. So from 2.5 hours with the default settings using the CPU only, not having the global illumination alternative, so using the AO option instead, and with a abnormally high sample rate of 4,000. It took 2 hours and 30, but now it took 47 seconds. So, as I mentioned earlier, possibly even more than 100 times. I don't know, do the math. Not too over-exaggerated, it seems now. So this is mostly it. And let's take a look at the quality, if it differs or not. So for the blurriness, just know that we are using the actual depth of field, so it does blur things out a little bit. So for the depth of field, it's 2.4, which is extremely low. We've got this, but as you see, our biggest trade-off was not any of the settings that we added, except the actual film pixel filter. So let's set this to 1.5. And let's try a second render and compare the quality. It won't be too much a difference on YouTube specifically, but it's something to consider. And we will see even lower render times. Why? Because we jumped the computation of the initial data at first and initializing the actual render. Remember, persistent data, this is where it comes in handy. Extremely useful and something that honestly should be set to default. So how much time did this take? The previous one took 48 seconds and this one took 33 seconds. Excuse me. Extremely low, extremely fast. And for an animation, that would be amazing if each frame with this sort of lighting, with our mist, with our fog, with as many objects and as many vegetations and scattering objects and instances, taking 30 settings. You can't really do better than that, which is amazing. Now, ideally for still frames, what will I recommend? I recommend that you keep the pixel filter off, and in the actual performance, keep persistent data ticked, and for the volume, depending on what you are actually doing. So if you're having any type of glass in your scene, make sure to set the transmission to 3 at least, or 4 at least. Diffuse and glossy can be kept to 2. It's fine, doesn't make too much of a difference. You're using caustics, I wouldn't recommend that you use caustics inside of cycles. Not the best option. Try to fake it with caustic maps. Try to fake it with actual overlaying a look score render, for example, on top of the Blender Cycles render. This is something very common. I also recommend that you take off fast GI approximation for stills. So instead of, for example, taking 1 minute, it will take 2 minutes, but the realism will improve and you don't really want to go ahead and risk realism as much. It's worth it. I'm not saying it's not worth it for animations, but for stills, 2 minutes won't really make a difference. I hope it won't make a difference for you at least. So this will be the end of our video. I hope it helped you and I am certain it did. If you do like it, feel free to subscribe, drop a like, and I would greatly appreciate if you make your own comparisons, send them over to me on my Instagram or drop them on the Discord. If you happen to follow any of my tutorials, make sure to send me the result and I will be more than glad to share it around and give you some feedback. So until next time, take care and enjoy yourself.